A very good afternoon, one and all present here. Myself, I am Girish P, Assistant Professor, Department of Civil Engineering, Vidyavardhaka College of Engineering, Mysuru. So we have here regarding the GATE 2022. So I had a total experience of 22 years in the Vidyavardhaka College of Engineering. Today in this GATE 2022 online training, we have discussed briefly onto the geoinformatics engineering. The more important, highlighting the concept of geomatics engineering to the GATE training classes. So coming to that, the discussion part of today's online training, we have a principles of surveying. So in that we have focuses mainly on the map scale, and distance and angle measurement details, and also includes the part of photogrammetry and remote sensing. So particularly in the part of remote sensing, we have discussed the scale, flying heights, and basics of remote sensing, GIS and GPS. So coming to the today's part, the remote sensing, geoinformatics engineering. Coming to the history of remote sensing, it is not a new subject. In olden days, we called it as a photogrammetry. The invention of this subject in the year 1690s by telescope, the Galileo invented telescope. From that day to till date, there are a lot of innovations. So only thing, the oldest or olden subject improved by adding a latest technology. The improvisation of this subject remote sensing through the various steps in the various level, including balloon photography in the year 1858, then aerial photograph in 1859, then capturing the data by using pigeon cameras from the year 1903, and aircraft or spacecraft from the year 1947. So the overall development of remote sensing in the recent last 2 decades was very much the higher way, and also a lot of contribution to the society. A brief introduction to the photogrammetry and aerial photograph. When I say photogrammetry, the graphical representation by means of light without physical contact with the objects. So any photography or any GIS or remote sensing related work, so always it will be means of a graphical representation without any physical contact. So similarly, aerial photographs, the photographs which are taken from aircraft or any other flying object from the fixed position. So to capture the major objective or aim is to capture the objects. So when I speak of aerial photograph, the first aerial photograph in the year 1859 by Grasper Felix, the first aerial photograph taken using a captive balloon from an altitude of 1,200 feet over a Paris. So that is the first aerial photograph. Then slowly improvised in the technique and sensor system. So now the aerial photograph will be converted to a aerial photograph, and then aerial photograph to the satellite sensor photos. So now present we have whatever that data we have received from the sensor system, all are having a automatically like corrected with the center projection, and we have received the data for any specific area. So this is the picture that shows the graphical representation, the definition of photogrammetry, the graphical representation by means of light without any physical contact. On the one hand, we have a camera, and on the other hand, we have an object. So this is the way that the sensor camera will going to be capture the data. So that data will going to be utilized for n number of applications in the daily day-to-day. Coming to the photographs, there are different types of photographs. So namely a few of one like a terrestrial photograph, bird eye view photograph. The same area, if you see the comparison between these two photographs, terrestrial photograph, just a photograph covered from a single point, so with an intentional angle. So this is the another photograph of that area, the bird eye view photograph covering a larger area. The bird eye view, the photographs are taken from the aircraft or maybe helicopter using the friction cameras. So friction cameras, basically they are high resolution camera. They are called aerial photograph. So there are many the varieties of camera, aerial camera, and this camera will be specifically designed for the use of aircraft, aerial film. This will be the high sensitive or high sensitivity film. So mainly so to capture the image with a stable emulsion. So that will the aerial films will going to be play an important role. And when I say aerial photograph, so it is the art, science, and technology of taking aerial photograph from an airborne platform. So these are the images of that the aerial photo, like aerial camera, to take a airborne platform photographies, and aerial photograph that it was completely taken by airborne platform by using a friction camera. Friction cameras with a specific high resolution the sensor lensing system. Coming to the procedure of aerial survey, there are many steps we are followed for capturing data. So nowadays, the sensor system is going to be automatically calculated and overlaying and overlapping images that we are obtained by the advanced sensor camera system. But earlier, so people will follow a specific procedure for capturing the data for in a particular area. A important set of parameters are considered for the aerial surveying is to altitude of flight, that is H, focal length of camera, that is defined by F, size of photograph, then alignment of land to be photographed, lateral overlap, photograph in each flight and parallel flight line, scale of flight map, speed of aeroplane, time interval of successive photographs. So these are the most important parameters that we are always considered during the aerial survey. After this, we are going to be take a photograph for preparing aerial photographs. So when I say aerial photographs, so always it would be based on the position, or it will be completely depending upon the axis of camera. On that basis, we call the different types of photographs like vertical photographs. While taking the vertical photographs, the two distinct axes are formed from the camera lens center, one towards the ground plane and other towards the photo plane. So on the other hand, I will show with the images how that vertical photograph, that is ground plane, and towards the photo plane, that will going to be captured the the object in a particular or in a specific area. The second type of photograph, low oblique photographs. So in which, in this case, photographs are taken with an intentional deviation in order of 15 to 30-degree camera axis. So in the image, I will show how that inclination of camera 15 to 30 degrees, the intentional, the camera axis. So thereby, it will going to be captured a particular area of an area to help us to prepare a type of photograph that is a low oblique photograph. So these are the some images of the aerial photograph to represent the vertical photograph, the same area, the vertical photograph, the same area in oblique photograph, because of the intentional changes in an angle. These are all the various things happen in preparation of aerial photograph. Then high oblique photograph, so with an like a inclined intentional inclination about 40 to 60-degree from the vertical axis. So it helps to capture the very larger area, a very wider area at a time, by using a scale ratio in order of the intentional scale, maybe a 1 is to 20,000, 1 is to 50,000, etc. So based on the scale, we call the different types of photograph with a scale 1 is to 15,000 photograph, and then 1 is to 20,000, 1 is to 40,000 photograph. These are the scale of photograph with respect to the same area with an intentional deviation of different types of photograph. Coming to this, the gate questions. So there are many times in the gate question, the expected question may be particularly on the development of remote sensing. And also there are many times one or two questions always expected, particularly on overlap or scale of map. With respect to that, we are going to be discuss the various overlap and scale of map related problems. The reasons for overlap: arrangements of mosaic, remove errors due to the displacement, for viewing in stereoscope, that is 3D view, and avoid repetition of aerial survey. So there are many procedures that we have followed, particularly the longitudinal overlap and lateral overlap. So overlap, it is a technique in which all the collected aerial photograph will going to be merged together and prepare a one superimposed aerial photograph. Overlap, in the case of longitudinal, it will be cover 50 to the 70%, and whereas in the overlap of two alternative photos in the longitudinal overlap will be covered 10 to 20%. Whereas in the lateral overlap, adjacent flight lines with a slide overlap should be in between 20 to 30%. Coming to that, the importance we are given to the scale of photograph. So if you set of the scale of photograph, the calculation that I have shown, particularly related to the scale of photograph, the distance between 2 points of an aerial photograph is measured as a 2 centimeter. The known distance between the same 2 points on ground is 1 kilometer. Compute the scale of aerial photograph. So for getting a scale of photograph, the equation will be SP, that is scale of photograph, is equal to the DP, the distance of photograph, and distance of ground, or distance of ground with respect to the selected points. So with this equation, when we start calculating the scale of photograph, the DP is 2 centimeter, and the total distance of ground will be 1 kilometer. Then the scale of photograph is equal to 2 centimeter, so converted into a centimeter. So thereby we get a scale ratio in order of 50,000. The 1 is to 50,000. So 1 unit represents a 50,000 units. So this is the way that we are going to be calculated the scale of photograph in any aerial photographs. The scale of photograph in this particular problem, that is SP is equal to 1 is to 50,000. Similarly, some other problem, particularly on aerial photograph, the photography establishing relationship between the photo distance and map distance. The distance between the 2 points, both on a map and aerial photograph, enable us to compute the scale of aerial photograph, that is SP. The relationship between the two distance may be expressed as the photo scale, photo distance, map scale. Then the equation ratio will be photo scale is to map scale is equal to photo distance is to map distance. So from this we can derive a equation SP is equal to scale of photograph is equal to DP is to DM into MSF, that is map scale factor. With respect to this, the calculation problem, like the distance measured between the 2 points on a map is 2 centimeter. Corresponding distance on a aerial photograph is 10 centimeter. Calculate the scale of photograph when the scale of map is 1 is to 50,000. To derive this, we have very much familiar about the photo scale, that is SP, then photo distance, map scale factor. SP is equal to, already we know the equation, the photo scale is equal to dp, that is photo distance, is to dm, that is map distance, into map scale factors. Sorry. Then we are derived the photo scale SP is equal to, that is dp is 10 centimeters, already they have given, into dm, that is already they have mentioned 2 centimeter, into the 50,000. 10 centimeter converted that into a centimeters. Then the scale of photograph or photo scale, 1 unit represent 10,000 units. Therefore, SP is equal to 1:10,000. This is the way that we are going to be calculated the scale ratio of a map. Similarly, problem related to the scale of photograph. So in this, by establishing the relationship between the focal length and flying height of an aircraft. So the photo scale is equal to focal length is to flying height. So related to this, we have a problem. Compute the scale of an aerial photograph when the flying height of an aircraft is 7,500 meter and the focal length of camera is 15 centimeter. Already we know that scale of photograph SP is equal to F is to H. They are given like 15 centimeter, that is focal length, into 75,000 meter, that is height of aircraft. So 1:75,000. So then SP is equal to 1:50,000. The scale of photograph is equal to 1:15,000. So this is the way that we are going to be establishing the relationship of the any aerial photographs. Maybe a vertical photograph, maybe a oblique photograph, or any other the different types of photographs. Furthermore, coming to the introduction part of remote sensing, already we discussed remote sensing, that is it is nothing but a large area from the sky which can be done by aerial survey or through the satellites which revolve around our earth at an altitude of 700 to 900 kilometers. Or in other words, it is the measurement of information about an object without being in physical contact under the study. So this the picture shows overall concept of remote sensing, how that energy illumination taken place, and as a result of illumination of energy, how that energy refracted back, or the re-emitted radiation energy, that reflected energy will going to be captured by the sensor camera at a various platform. So that captured data will going to be like through the receiving station, that we are going to be downloaded the data, and finally we are processing and complete the remote sensing concept. Many a times, particularly the remote sensing part, that is always depends upon the electromagnetic spectrum. So when I say electromagnetic spectrum, always we have very much careful towards the bandwidth or wavelength frequencies. When I say wavelength, generally the spectrum start with the shortest wavelength portion to the longest wavelength portion. So in this image, it was clearly shown that the shorter wavelength, that is a cosmic rays, X-rays, ultraviolet, near infrared, middle infrared, thermal infrared, microwave, and radio waves. So X-rays are the shortest wavelength portion and the radio waves are the longest wavelength portion. So here, in all the various the electromagnetic spectrum, that is X-rays, gamma rays, ultraviolet, infrared. So particularly in the middle of ultraviolet and near infrared, we have a small portion called visible portion. Among all the various spectrum, we are given more importance to the visible spectrum, because visible spectrum, it is the only the one electromagnetic spectrum that was greatly represented or characterized with sets of color. So if you see the image, it was clearly shown that how the color bandwidth, that is the visible portion, shows that the ultraviolet to red color. So whereas in the normal electromagnetic spectrum, the radiation spectral frequency will be varies from a 0.004 micrometers to 100 meters. Whereas in the case of electromagnetic spectrum, the spectrum frequency will be varies with 0.4 micrometers to zero point 0.7 micrometer. In the visible portion, zero point 0.4 is the shortest wavelength portion and zero point 0.7 will be the longest wavelength portion. So starting with violet, that is a shorter wavelength, and red will be the ended with 0.7, that is a longest wavelength portion. So in between that, the blue, green, yellow, orange, they are the various bandwidth with different frequency. So most of the time in the gate, expected question focusing on particularly the wavelength frequency of a various spectrum. So in the in that aspect, so the wavelength frequency includes blue color, green, red, infrared, middle infrared, thermal, and microwave. So coming to the electromagnetic the radiation, so interaction of radiation with the atmosphere. So that mainly always with respect to the absorption and scattering effect. So absorption in the atmosphere and the scattering effect. So that these are the two important the processes will play an important role in electromagnetic radiation interaction to the atmosphere. So as a result, the scattering, the process will be always adverse effect on remote sensing. So scattering the process that always depends upon the various factors, including the condition, including the light conditions and the various temperature factors. The scattering adverse effect greatly on remote sensing, including it will always reduces the image contrast, change in the spectral signature of ground object seen by the sensor. So that all depends upon a types of scattering. There are two types of scattering: Rayleigh scattering, Mie scattering. So particularly when I speak about the Rayleigh scattering, so the particle size radiation wavelength inversely proportional to the fourth power of wavelength. So in the case of Rayleigh scattering, the shorter wavelength electromagnetic radiation is scattered more because of the mechanism involved, that is the radiation, the particle size radiation wavelength inversely proportional to the fourth power of wavelength. So that's why, because of this Rayleigh scattering effect, we have a sky, it looks blue. And the effect on photograph can be minimized by using a filters which prevents the transmission of shorter wavelength, that is electromagnetic radiations. And another type of scattering, Mie scattering and non-selective scattering. In the case of Mie scattering, atmospheric particles diameter equals to the energy wavelength being sensed, and it is caused by water vapor and dust. So mainly the Mie scattering influences the longer wavelengths, whereas another one, the scattering, that is non-selective scattering, it always occurs when the particle size much larger than the energy wavelength. And the non-selective scattering are always a water droplets cause such scatters. And always the fog and cloud appears white or whitish, or appearance of sky, that mainly because of due to the non-selective scattering, in which the particles larger than the energy wavelengths. Coming to the stages in remote sensing, so first stage will be the origin of EMR, that is electromagnetic radiation. The second will be the electromagnetic transmission of electromagnetic radiation from the sources and its interaction with the atmosphere, interaction of electromagnetic radiation with the Earth's surface features such as forest, water body, and soil, and transmission emitted EMR, that is electromagnetic radiation, to be remotely sensed, then sensor data output, data processing and analysis, generation of output. These are the important stages in process of remote sensing. Always that process include the standard reflectance curve. So this the image shows the standard reflectance curve for the electromagnetic spectrum. So standard reflectance curve like vegetation, soil, water, clear water, turbid water, so etc. So when we look onto that, the reflectance curve of vegetation, so particularly in between zero point 0.7 to 1.4, the wavelength frequency, the the reflectance will be very high. So that all depends upon the reflection and reflection of the type of the objective in which the sensor will going to be censored. So when the sensor will going to be censored, the all such the various the whatever that the object interaction or elimination of radiation taken place. So that all depends upon a type of remote sensing platform. When I say platform, like ground-based platform, aircraft platform, space shuttle platform, and satellite platform. So these are the various pictures of different types of a platforms, and that depends upon a type of a sensor. So the collection of data from the platform, that depends upon the type of a sensor, like by the data will going to be collected by satellites involving high altitude and low altitude through the ground observations. So depending on the collection of data, we call a geostationary sun synchronous satellites and polar satellite platforms. When I say satellite platform, so to basically to launch and do the platform of a sensors at arbitrary path for collection of data. When we collect the data through the sensor system, there are two types of a sensor system: passive sensor system and active sensor system. When I say passive sensor system, a good example, human eye, camera, and radiometer. So in which the passive sensors can measure the energy that are naturally available during the daytime. So particularly the passive sensors, they are very much accurate, particularly when natural energy radiation is available. Whereas the active sensors, in which it will provide their own source of energy or own illumination energy, and the advantage of this active sensor is to, like, it has the ability to measure the object at any time regardless day or season. So with this, today I'm going to be completed the training class, and the next section I continue in the whatever that allotted interval timings. Thank you for listening. Good luck.